Don't forget to subscribe and ring that bell.
Hey there, hey there, hey there. We are going to continue the 2013 AP Calculus AB practice exam that College Board lovingly gave to us. We are going to do free response question number 2. This is the final question for section 2, part A. This is the last problem that we get to use a graphing calculator for on this exam. Don't go, Mr. Calculator, don't go. But don't worry, we got this, okay? And speaking of graphing calculators, the calculator I use in this software, the calculator set that I have in my classroom, and my own personal graphing calculator is the TI-84 Plus CE, the color edition. I love the graphing on the screen, how I can graph two different equations or functions with different colors. It really makes things easier. And the display is just a lot nicer than the regular TI-84 Plus. It's a whole slew of colors. I dropped the links in the description below. If you want one, check them out. If not, no biggie. And I got the supreme color that I love. My personal one is the mint green. Boom. Ooh, so pretty. Let's get started. Number 2 reads, the penguin population on an island is modeled by a differentiable function p of time t, where p of t is the number of penguins and t is measured in years, for t in between 0 and 40 inclusive. There are 100,000 penguins on this island at time 0. The birth rate for the penguins on the island is modeled by b of t, which is 1,000 times e raised to the 0.06 t in penguins per year. And the death rate for the penguins on the island is modeled by d of t, which is 250 times e to the 0.1 t penguins per year. 2A is asking, what is the rate of change of the penguin population on the island at time 0? When I first started doing this, okay, I used to, get all, not confused. I think I thought about it too much. But really, this is a very, very simple thing. All right? So, what is the rate of change of the population? Which means I got to compare the penguins being born, because that's going to raise the population, to the penguins dying, because that will lower the population. Both of these have to be at time equals 0. Well, I have these rates already. So really, I just got to find the difference. What is the rate that they're being born at time 0? And subtract the rate that they're dying at time 0. That's really all they're asking me to do. And because I have a calculator, which I really don't need in this situation, but because I have a calculator, I could really type that right in the calculator. All right? So if I put a 0 into this right here, I get 1,000 e to the 0.06 times 0, okay, minus the death rate. That's such, I just feel so horrible saying that, okay, which is 250 e to the 0.1 times 0. Here's the great thing about this, all right? Great. Anything times 0 is 0, this exponent. Same thing here. Anything to the power of 0 is really 1. Okay, so it's 1,000 times 1 minus 250. Also, because e to the 0 times 1. So I end up with 1,000 minus 250. And that rate of change for the penguin population is 750. Okay, they don't ask for label or whatever, but it is increasing. It's a positive number because there are more being born than dying, and that would be penguins per year. Okay, if I wanted to write that. 2b, to the nearest whole number, what is the penguin population on the island at time equals 40? All right, here we go. Quick little review time. We have penguins per year. We have a rate, our born rate or our birth rate and our death rate. These are both rates. They want to know to the nearest whole number the population. They want to know penguins, just penguins. Yeah, penguin. There was an N here. I put penguins, right? Which means I got to go backward from the rate, which means I got to integrate. Okay, starting from time 0 all the way to time 40. So to the nearest whole number. So at 40, how many penguins were born? So I got to integrate that. And how many penguins died? And I got to figure out that total. How many are left on the island? Okay, so I'm going to integrate B of t minus d of t, because I got to figure out how many are born and subtract how many passed away or died. All right, dummy variable anytime I integrate. My bounds starting from time 0 to time 40. That's what they give us here. Okay, but there's one thing we're missing. If I go back to A, there are 100,000 penguins on the island already at time 0. So before I do any of this math right here, there's already 100,000 penguins there. So I got to add 100,000 to whatever number I come up with here. And this is what I'm putting in the calculator. All right. So let me bring this up here. And depending on how small the screen is on your device, or how big, depending on whether you have, like, you know, an Android, I love those phones with the S Pens. I love them. I got an S22 Ultra, but that's for another day. Detached LCD. This makes it bigger anyways. Turn this on. Now I'm going to take my 100,000. Yep, there it starts with a 1. And I'm going to add the integration, math 9, from 0 to 40 of, okay, my B of t. And B of t, which is on part 2A, all right, is 1,000 e raised to the 0.06. It is t, but we use x in the calculator. That's B of t. I've got to subtract the death rate, which is 250 e raised to the 0.1x. All right, pop out there. My dummy variable is an x, and we hit enter. There we go. At the end of, what was it, 40 years? Our time was in years. We have 133,057.56. All right. They want us to round that to the nearest whole number. Okay, so this 7 will go up to an 8 because the number is 5 or bigger after it. So 133,058. And of course, that'd be penguins, and I'll make sure I put the engine. I'm just abbreviating that. There we go. Pretty simple. 2C, and believe it or not, we're done. This is a quick video. To the nearest whole number, what is the average rate of change of the penguin population on the island for time between 0 and 40 inclusive? All right, a couple of things. There are actually 2 ways to do this. I will show you both ways since we have time. We will go with something nice and about orange. Yeah, that'll work. Okay, so whenever they say average rate of change, that's really the slope between 2 points. Okay, it's a slope between 2 points. What do I mean? Well, that's the change in y over the change in x. But in our instance, we have the change in population, P of t, I guess 1 times 1, minus P of t a second time, all over t1 minus t2. Or I can really make this 2 and then 1, just to stay the same as we have here. 2 and 1. Okay? Now, time is from 0 to 40. So let's say that this is time 2 and this is time 1. So the bottom Okay, I'm going to do this right here, right down here. The bottom of my fraction is going to be 40, which is time 2, minus 0, which is our starting time 1. So I need to find the population at 40 and the population at time 0 and subtract them. Guess what? In 2A, they tell us at time 0, there's 100,000 penguins. And guess what we did in 2B? We just found the population at 40. That's what this was. Okay, the population at time 40. Okay, 133,058. So I can say 133,058. All we've got to do is put this in the calculator and hit enter. That was really easy. This part was given. This we did in 2B. We literally used information from the problem initially and our previous calculation. All right, so let's go here. Here, and here. Turn this on. Anytime I have a fraction, I like to use the fraction function. On my calculator, it's alpha y equals enter. And I'm going to put 133,058 minus 100,000. Yeah, there you go. And I'm going to put that over 40 minus 0. Ooh, it gives me a fraction. It actually reduces. So if you want to know that number, I'll just take my 16,529 divided by 20. And I'm sure there's other ways. If you go to the math menu and you could just have that converted, I just do it out. 826.45. So if I have to round to the nearest, okay, this is 826.45. They're saying to the nearest whole number. This will stay as 6 because the number after it is less than 5. So the answer is 826. Okay, that's the average rate of change of the penguin population. Okay, so that would be penguins per year. Beautiful, 826. Now, I said there was a second way to do this. Okay, and I'll show that to you. This was by far the easiest way to do this. But we can also take a look at, more specifically, let's get the thinner one here. When it says average rate of change, that's really the average value of the rate of change. All right? Which means average value is integration. If I'm integrating from 0 to 40, I also got to multiply by 1 over that difference. And how do we figure out the average rate of change? We have to add up, right? We have to add up our rates of changes. So I take our birth rate minus our death rate. Okay? That's what I do. If I want to add up all those values, right? I can do that and you end up getting the same thing. If I put that in a calculator, you'll end up rounding, getting the same answer, 826. However, whenever it says average rate of change, I just like to have the 2 points. I mean, you could see in orange how much easier it was to do. Problem 2D, the final part of problem 2, reads, to the nearest whole number, find the absolute minimum penguin population and the absolute maximum penguin population on the island for time values between 0 and 40 inclusive. Show the analysis that leads to your answers. Okay, a couple of things we need to kind of recall here, and I'll do green, will be the birth rate. Okay, they give us the birth rate of the penguin, all right? And then they also give us the death rate of the penguin. Obviously, when penguins are dying, the population is going down, all right? And when the penguins are being born, the population is increasing. We've got to consider both of these because both are happening at the same time. So our question is, when is the birth rate bigger than the death rate? Because if more penguins are being born than are dying, my overall population will be on the rise. And likewise, we need to see when the death rate is bigger than the birth rate. In that case, my population, more are dying than being born, so the population will be going down. So I've really got to figure out where this happens, where this changes. Because at some point, the birth rate is more. And then at some point, the death rate is more. At some point in our interval. That's where I've got to kind of find out. And oh, let us not forget, at time 0, we already have 100,000 penguins. All right? So the first thing I'm going to do is I'm going to grab that calculator. Love it. And I'm going to put in the calculator the graph of B of t and the graph of D of t. And what I'm going to do is I'm going to use those same colors. So my birth rate will be the green graph, and my death rate will be the red graph. So let's get this calculator up and going. So we'll go to y equals. And in green was the birth. I mean, this is why I love this color addition. I got to be honest with you. Sorry for the shameless plug. But it's 1,000 times e to the 0.06 t, or in this case, we use x in the calculator. That's my birth rate. And I want to compare that to the death rate, which is 250 e to the 0.1 t. Okay, and again, we're going to use the x as our t variable. Now, my window. My x-axis represents time, and we want to go from 0 to 40 years. All right? We start with 100,000 penguins, but we're not concerned about the quantity. Okay, we're concerned about the rate. So I'm going to start at 0, and I'm actually going to go to my table. I'm going to go to table set here, and we go up to 40 years, don't we? So let's start at year 40 and look at my table. Notice my death rate in red is 13,650. My birth rate at year 40 is 11,023. So I just need to pick a number that's slightly bigger than both of those, so it includes both of those. I don't know, maybe 15,000, 14,000? Let's pick 14,000. Okay? So let's go back to my window, and my Y maximum is going to be 14,000. And I want to go, I don't want to see 14,000 tick marks. Let's make one tick mark every 1,000. Okay? So let's graph this bad boy. This is the representation of my death rate. That still gets me, the death rate. So morbid. And this is a representation, the green line, of my birth rate. Right there. Right here is where they intersect. Okay, right there. I want to find out when that is. Because what that tells me is, my birth rate is bigger here than my death rate because it's higher up on the graph. So more penguins are being born, so my population is increasing. So right there, my birth rate is bigger than my death rate. So my population is going to be increasing from time 0 until I hit this time right here. After that time, after I pass that blue point, notice the death rate is bigger. So more penguins are dying than being born, so my population will be decreasing. When? From this point of intersection all the way to 40. Okay? So I'm losing penguins after this line, and before this line, I just keep on increasing or gaining penguins. All right? But they're asking us how many. What is the maximum population? Remember, I'm going to have to integrate my rates to get my quantity. So the first thing that's important is I want to know what this point of intersection is with a question mark. All right? So let me get rid of all this. I know I didn't touch you in a little bit. Now you're getting salty. There you go. So let's find the intersection. I'm going to go to second, trace, intersect. I'm just going to enter 3 times. 1, 2, 3. All right, so that is 34.657. You see that bottom left? This is my point of intersection. All right, 34.657. In fact, let's do this, bring this out here. Put this right here. So at this point, 34.657. All right. So what I need to do is I need to take my 100,000, okay, and I need to add that to the integration from 0 to 34.657. Because I want to add up all the births and take away all the deaths. Keep in mind there's more births than deaths, okay? I can't just add the births if I want the population. I got to include those penguins that pass away. So I'm going to take B of t minus D of t, and don't forget our dummy variable. It's very important. And I want to the nearest whole number what that's going to give me, okay? Now, for problem 2b, we did something similar, but the upper bound was 40. Because remember, they wanted to find the number of penguins at 40. So I can't just look at 2b and get the answer for this part. All right? So let's go back to our handy-dandy calculator. I'm going to hit X because I want to see that number. I am not going to round my upper bounds until the answer is I shouldn't do any rounding until I get an answer. So I'm going to take my 100,000. I'm going to add the integral, math 9, from 0. Then up here, I'm going to just hit enter when I highlight that decimal, and it's going to put that in the upper bound for me. B of t, which is 1,000, times e to the 0.06x. Remember, we're using x in the calculator, minus the death rate, 250 e to the 0.1x. Pop off there. Make sure I get my dummy variable, and then hit enter. 139,167. That 6 before the decimal will round up because the number after the decimal is 5 or bigger. So 139,167. 139,167 penguins. This is the most penguins that will be on the islands. How do I know that? At this point of intersection, that's how many penguins I have. After that point of intersection, more penguins are going to be dying than born, which means my population will be decreasing. Okay? So now, if I want to figure out how many penguins are on the island at time 40 years, okay? So at this point, on the x-axis, well, I could, that's this line right here, I could take the integral from this to this, find out what that number is, and subtract it from 139,000. Or I could just take the integral from the beginning, meaning I take the integral from time 0 on the x-axis to time 40. That will take all of these, which we have, and then it'll include all of these. It'll total everything up, and we'll subtract that for us. And that, my friends, we already did do on 2b. I love when we get to use previous work, the integration from 0 to 40. Okay, I'll scroll this so it's in the middle, of b of t minus d of t, dummy variable. Okay, let's go back to 2b and figure out that was. This is what we have. 133,058 penguins. All right? So I can't just write 133,058 without showing the integral. How come? Because remember, show the analysis. We got to show how we got the answer. So it was 133,058 penguins. Okay? That's at time 40. So after our point of intersection, and let's really understand what's happening here. Up until our point of intersection, we kept on getting more and more penguins because more were being born. And we ended up with 139,000. But after that, from 34 to 40, we started losing penguins. We lost, I don't know, about 6,000 penguins because at time 40, we have this number now. That's because the death rate was more than the birth rate. However, 133,058 is not the least amount of penguins on the island. Please keep in mind that on our interval of time, come on, there you are. On our interval of time, they want us to go from 0 to 40 and include 0 and include 40. Remember at time 0, We said there were 100,000 penguins. To me, 100,000 seems to be less than 133,058. At time 0, or at our start, there are 100,000 penguins. This, my friend, is the least number of penguins on the island. All right? Not at time 40. Even though we're losing penguins, we haven't lost enough so that the number went below where we started yet. So we're 100,000 at time 0. That is the least amount of penguins you have. At time 34 years and change, I guess we'll call it, we had 139,167 penguins. That is the most. We are done. Thank you. It sucks that we're not going to get to use our calculator moving forward on this test, but you know what? As much as I love to use that calculator and all those fancy colors, I also love doing that math mentally in my head. I love doing that algebra. It's great. And hopefully I will see you for problem number 3, free response question number 3. We'll see you later. Stay warm if you're in the Northeast in the U.S. It's getting cold.
Don't forget to subscribe and ring that bell.